Hello everyone, I'm Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course operating system. We are learning deadlock avoidance concept. In our last video, we have understood the first step of deadlock avoidance banker's algorithm. Deadlock avoidance can is of two ways. First way is if we need to consider whether the resources are of single instance or the resources of multiple instance. If the resources are of single instance, we need to go with the resource allocation graph, which helps us to check whether the system is in safe state or not. If you have multiple resources, then we need to go with the banker's algorithm. In the last video, we have learned like banker's algorithm is a two-step process where we have the first step is to check whether the system is in a safe state or not. That can be done by using the safety algorithm. I hope you all have gone through that video and understood. So using the safety algorithm, we will be finding the sequence of process execution where it if we could able to find that sequence, then it is called as a safe state. Then the system is in not in a deadlock. If it is not, then the system is not in a safe state. Okay. Now, after some time, suppose if a process has requested for some additional resources, then the operating system, instead of directly allocating the resources, it will go through this resource request algorithm. It is having some steps, and after following those steps, uh, again it will run that safety algorithm, and after running that safety algorithm, if the operating system could able to generate a safety sequence, then it can ensure like if the resources that are requested by the process can be allocated. But if you could not generate the safety sequence, then the system may lead to unsafe state. Then the operating system can come to a conclusion like that may lead to deadlock. So we will avoid allocating these resources. Right. So let us see what is the safety this resource request algorithm. So the resource request algorithm have some set of steps. We will see what are all those steps. Keep your heading, all of you. Resource request algorithm. So these are all the steps. For your understanding, I have written here. Make a note of all these steps. We will understand what are all these steps in detail by taking an example, and we will run these here. We will go through these steps. Okay. Keep heading, all of you. Resource request algorithm. Now, what is this resource request algorithm says is, if first what we see a process will be requesting for some resources, right? The resources are the resources have multiple instances. We already know banker's algorithm will be applicable for multiple instances, isn't it or not? Suppose let us consider the same example that we have considered for our safety algorithm. Okay, what we have considered there is the number of resources for A is something like I think we have considered the number of resources for A is like 10, and B resources of 5 instance, and C resources of 7 instances, isn't it or not? We have considered like that. So the same example we will consider. We have considered A resources are of 10 and B of 5 instances and C of 7 instances. Instances is nothing but that many number of copies. That means your system may have 10 printers connected. That means printer is one resource, but it is having 10 printers connected like that. Okay. Now, if these are the resources available and we have some processes, let us consider some set of processes like 5 processes. Let us consider what is the need and what is the allocated at particular time, and what is available. All those things, let us consider the same problem, what we have learned in the last class. Now, after some time, let us consider one process has requested for some additional resources. Some additional resources of A, some additional resources of B, some additional resources of C. Now, what is this resource request algorithm does is it will first check whatever request the process has requested, is it less than or equal to the need, because we already told each process need to give maximum, like what is its need, right? So the recent request should be less than or equal to need. If it is less than or equal to need, then only it will go to the second step. Okay, in the second step it will check if the requested resources are available, that means it is less than or equal to available, then only it will go to this third step where it will update the available, update the allocation, and update the need variables. And after updating this one, we need to go through the safety algorithm that we have learned in the last class. And after running through the safety algorithm, if we could able to determine a safety sequence, then the resources can be allocated to the particular requested resource, particular requested process. But if you could not find a sequence, then the resources requested by a process will not be assigned. Okay, to understand this even more better, let us take the example. The same example I'm taking. What is the example I'm considering is, let us consider at a particular time. These are the processes that are considered. Okay, 5 processes let us consider, and each process maximum is mentioned here, and allocation is given here, and these after allocating like this at a particular time t naught, the availability is like this. You all know how the availability has been calculated, how the maximum is 7. Okay, out of which we have allocated for a resource A 2, 3, 5, and plus 2 is 7. Out of 10, 7 has been allocated, so available is 3. Got it? And out of 5, who has been allocated, so the available of B resource is 3. Got it? Out of 5, out of 7, 5 have been allocated for all the resources, then 2 is left. So this is available. Right? Okay. Now, at a particular time t naught, this much has been allocated. So how much is remaining required? That is your need matrix. You all have understood that also. So let us make a note of that need matrix also. Okay, so this is the need matrix for each. After allocating, this is the need matrix of each process. Okay, so what is the need matrix? How you got the need matrix? You all know, a maximum required and allocated. Maximum required minus allocated. So 7 minus 0 is 7. For 5 minus 1 is 4, like that. You already know, in the last video we have understood how these matrices can be generated. Okay, all right. Now this is at a particular time t naught. Okay, and we have run the safety algorithm in a last video, and we could able to generate the safety sequence. Okay, that means the system is not in a deadlock state. But after some time, at time t1, okay, let us consider the process has requested, let us consider P1 process, make a note all of you, P1 process has requested resources for A. It is the request by P1 process, A, B, C resources. It is requesting one resource of A, 0 resources of B, and 2 resources of C at a particular time T. T2, let us consider. This is the request. Okay. Now, whether this request has to be satisfied or not, how to do this one? To do this one, what we need to do, the operating system, first it will take this request, it will run this resource request algorithm which is mentioned here, and then the values will be updated. After that, the safety algorithm has to be run again. Okay, let us do that. Okay, first step we will see, what is the first step it is told? If resource request, whatever request is given by the process P1 in our case is less than need or not. What is the first step? I will write here. What is the request? The request is 102. Okay, is less than or equal to, what is the need? What is the need of P1? Need of P1 is 122. 122. Is it less than or equal to 2? Yes, it is true. Then in that case, it will go to the second step. In the second step, what it is told? is the request is less than or equal to available. What is the request for process P1? Observe here, we are working for process P1. Okay. The request for process P1 is 1 or 2 is less than or equal to available. What is available of P1? Available of P1 is, not P1, actually the available is this one, 332. So 332. This is less than, yes, 1 is less than 3, 0 is less than 3, 2 is less than or equal to 2. So this is also satisfied. Then we need to go to the third step. What is the third step? The available has to be updated where the original value should be reduced with this request value. What is the available value? We have 332. Okay, so 332 minus what is the request? Request is 102. Has to be done 102. So this has to be updated in the available. So what we will get finally? 3 minus 1 is 2. So this will be updated to 2. And then 3 minus 0 is 3. So this will remain as it is. And then 2 minus 2 is 0. So this will be updated to 0. So this will be our new available value. After that, what we need to do? Allocation has to be added with the request. What is allocation of P1? We are talking about P1 process. Okay. Allocation of P1 is 200 plus what is the request? Request is 102. That has to be updated for allocation. Right. So what is 2 plus 1 is 3. So this will now change to 3. And 0 plus 0 will remain 0. Okay. And then 0 plus 2 is 2. So this has been updated to, got it? And then finally the need map, this step, need is to be reduced with this. What is need of P1? Need of P1 is 122. 122 minus request is 102. The need has to be updated. Okay. What is 1 minus 1? 0. So this has been updated to 0. And then 2 minus 0 is 2. And then 2 minus, 2 minus 0 is 2. 2 minus 2 is 0. I hope you all are clear till now. Got it? Okay. Now, after that, what it is told, you need to go through the safety algorithm first. We have to run the safety algorithm. So, let us run the safety algorithm and check. Okay, so what I will do, let us write the safety algorithm here, whatever algorithm we have earlier we learned, and that safety algorithm we will take and we will run this algorithm and we could able to generate the safety sequence or not. Let us see. Okay, so for your understanding, I'll write the safety algorithm once again. So the safety algorithm is this algorithm where it has some, I think, 5 steps. Let us make a note of all those 5 steps, because you need to have these steps to proceed further. Okay. So this is the second, third steps. And finally, we have our fourth step. The steps are very easy. You might have gone through the last video. You have understood how to do this one. Okay. Now, what we need to do, let us run the present status of our system through this safety algorithm and we could able to generate the safety sequence or not. Let us see. Okay. Okay, now let us run. Now, what it is told? It is told like we need to generate, we need to take one variable called work and work value should be equal to the available. So, let us take here itself, let us take work variable and that work variable is equal to your available. What is available? 230. So, work is now 230. Okay. Now, coming to finish of I, let us consider for all variables. Let us consider 5 processes we have considered. So, 5 processes let us consider 0, 1, 2, 3, 4. Okay. So, this is process 0, 1, 2, 3, 4. Finish of I, it should be initially false. Okay. So, let us consider for all false. That means their execution has not yet been completed. Okay. So, this is finish. Now, let us start with the process P naught. Let us start with the process P naught. Okay. Now P naught, what it has to do? It has to check finish of I is false. Yes, it is false, true. Now it will go with the need of I. What is need of P naught? Need of P naught is 743. 743 is less than or equal to work. What is work? You can see here 230. Is it less than or equal to 230? No, it is not less than, because 7 is not less than 2. So the condition is not satisfying. So P naught has to wait. As P naught has to wait, let us go to the next process. Let us consider P1 process. Okay, so let us take now P1 process. I hope you all are understanding what I am doing here. Now P1 process, yes, its value is false. Obviously it is false first. And the need of P1. What is need of P1? Need of P1 is updated 020. So 020 is less than or equal to work. What is work? 230. Check here. 0 is less. 2 is less than 30. So it is done. It is true. Then in that case, what we need to do? We need to go with the third step. What is the third step? Work equal to work plus allocation. So what is work? Work is 230. Okay. Plus what is allocation? Allocation of P1 we need to check. What is allocation of P1? 302. Okay. 302 has to be updated. 302. Is it 302? Yes. Work equal to work plus allocation. 302. It has to be, because after these resources are allocated, it will complete its execution and then we are releasing the resources. So work will be updated. What is that? 2 plus 3 is 5, and then 3 plus 0 is 3, and then 2 plus 0 is 2. So this is the updated work. Okay, and then finally what we need to do, the finish of that particular process has to be updated to true. So this has completed its execution too. So first what we have completed in our process, P1 is completed. Okay, okay, all right. Now let us go to the next process. Let us take another process, P2. P2. What is the P2? P2, we need to go again with this. Finish of I is false. Obviously, need value we will take. Need value of P2 is what? 600. 600 is less than or equal to work. What is the work value? 532. Is it true? No, it is false. So it has to wait. It can't do. So we will go to the next process. What is the next process? Let us take the next process is P3. Okay, P3, it will come here. Finish is true, false only. Need of P3. What is need of P3? 011. 011 is less than or equal to work. What is work? 532. Yes, it is done. True. Then what we need to do? We need to come and work has to be updated. What is work value? 532 plus allocation of P3 has to be added, right? What is allocation of P3? 211. So 211 has to be added and it has to be updated in the work. So what we will get? This will be updated to now 7. 3 plus 2 is 5 and 2 plus 1 is 3. Got it? Okay. Now after that what we need to do? Finish of I has to be done true. That means P3 is done now. It is true. So the next process we need to do is P3. Got it. Okay. Now let us go to the next process. Let us do P4. P4 process let us take P4, and P4 it is finished only. Now it has to take its need. What is P4 need? This is P4. Its need is 431, which is less than or equal to 753. Yes, it is true. Then in that case, what we need to do? The work value, which is 753, is to be added to the allocation of P4. What is that? 002, and the work has to be updated. Okay, now 7 plus 0 is 7. 5 plus 0 is 5. And then 2 plus 3 is 5. The work has been updated. And then finally P4 has to be made to true. That means the next process we have to execute is 4. Now we still have two processes waiting. Okay. So let us take P naught. Okay. Let us take P naught. Again, now P naught is false only. We will take what is P naught need. P naught need is 743 less than or equal to work. What is work? 755. Yes, it is true. Right. So as it is true, what we need to do? The work has to be added with the allocation. What is allocation of P naught? 010. 0, 1, 0, and work has to be updated. So 7 plus 1 is 7. Okay. And then 5 plus 1 is 6. And 5 plus 0 is 0. Okay. Am I doing anywhere wrong? 302. 302 did I add? No. P1, where it is P1? 302. 532. 532, and then P3, 532 plus uh, here 211, 7, 3 plus 1, 4. Yeah, here it is 4. Did you see? 5 plus 1, 2. Here it is 4. I hope you all could understand here. 4, 2 plus 1, 3. Then it is, uh, then we have come here 753. No, it is not 753, it is 743. Isn't it or not? 743 plus 002. Right. So 4 plus 0 is 4. It is 4 only. You don't get confused. Okay. I'm so sorry to confuse you. So 745, 745 plus 010. So 4 plus 1, now it is 5. Got it? So how can you know you have done it wrong or not? I will let you know. Okay. 750, 5. 5. Okay, 5 plus 0 is 5. 755 is done. Okay, now P, it has to be converted to true. That means the next process we have executed is P naught. Now the final process that is left is P2. Let us execute P2 also. So P2, what is its need? 743, right? Sorry, P2 is 600, which is less than or equal to work. What is work? 755, which is true. So what we need to do is 755 is to be added with allocation of P. What is that? P2. What is allocation of P2? 302. Okay, 302. Okay, now that has to be updated in the work. Now you see 7 plus 3 is 10. So finally work I will write here 10, and then 5 plus 0 is 5. 3 plus 2 is 7. Okay, so finally we have work this one. Okay, now P2 has completed its execution true, and final task is this one. That means we could able to get one sequence, and also whether you have done right or not, what you need to do, check this value with the original initial values of your resources. See, A resource is 10, B resource is 5, 7 resource is 7, C resource is 7. After completing its execution, they will release the resources, and we got A as 10, B as 5, and C as 7 only. That means we have done our work right, and we got one save sequence also. That means while after allocating the resources, after whatever P1 has requested like this, and after allocating the resources by following this algorithm, we got the updated values like this. Now, after getting the updated values, by passing through the safety algorithm, we could able to get one safety sequence like this. Did you see? Then we can say the system is in a safe state, and the resources, whatever is requested by the P1, can be allocated to the process P1 because it is not leading to a deadlock state. I hope you all clear with this one. But this may not be the case for all process requests. Like for your understanding, for your practice, I will leave here. Just try this one, all of you. Suppose consider the initial requests only, not the, here you have considered P1 request. Consider P4 has requested like this. P4 has requested resources of A3 and B3 and C0. Got it? Whether these resources can be requested or not? It cannot be requested. Why? Because the resources are not available. 330 available you see here 332. 230 we can't allocate, right? And also you see if P naught has requested the resources like this 0 to 0 resources, this cannot be also mm, uh, allocated. Why? Because even though it goes through the resource allocation, resource request, this one, resource request algorithm, it goes through this resource request algorithm, it will result in a unsafe state. I request you all to go through this safety algorithm. You could not able to generate one safety sequence, that means it is leading to the unsafe state. So this request and this request can't be granted. Got it? Why? P4 request is not granted. Why? Because it is requesting 330. We don't have 330 resources. We have 230. Right. And also, if P4 020, the resources are available 020. So the resources will be, a resource request algorithm can be gone gone through, but the safety algorithm, if you work with the safety algorithm, we could not able to generate one safety sequence like this. So that means the system is in a say unsafe state, then this request cannot be satisfied. Got it? This is about how the banker's algorithm will work and how it will help us in avoiding our system to enter into the deadlock state. I hope you all are clear with this today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.